I'm often asked my opinion about the cause or treatment of some medical condition, but the question to instead ask is, what does the science say? What does the best available balance of evidence published in the peer-reviewed medical literature have to say right now? Welcome to the Nutrition Facts podcast. I'm your host, Dr. Michael Greger. Today we bring you the first installment in our series on taurine. No, taurine isn't an astrological sign, it's a non-essential amino acid that our body can make, but does it make enough for optimal health? What are the pros and cons of supplementing? Let's start with a little background. Energy drinks are widely consumed in the United States, with sales exceeding 350 million gallons. There's only like 335 million people in the U.S., so we each average more than a gallon a year? Is it just the caffeine that people are after? A major ingredient in popular energy drinks is taurine. What is that? Taurine is one of the most abundant free amino acids in our body, free as in not incorporated into proteins. We make it in our own bodies, that's why it's considered non-essential, as in we don't have to get any in our diet. However, premature infants are vulnerable to taurine deficiency because they initially lack some of the enzymes needed to synthesize taurine, but breast milk provides all the taurine they need, and it's often added to infant formula as well. We aren't the only animals who make it. The name taurine derives from the Latin taurus, meaning bull or ox, because taurine was first isolated from the bile of an ox in 1827, decades before it was discovered in people. It's funny, in my search of the medical literature, I kept coming across articles on taurine surgery. What does that mean? That's what they call surgery for bullfighting injuries. Anyway, taurine was first isolated in the 1800s, but not much was known about this molecule until the 1990s, after we found low levels in preterm formula-fed infants. Even though taurine isn't incorporated into proteins, it plays important roles throughout our body. Clues to its importance include the fact that our body has not one, not two, but at least 5 pathways to make it, and we make a lot of it. If you look down at the bathroom scale and it says 200 pounds, about 1/5 of a pound of that is straight taurine. Other clues can be found in where it's made. The main pathway enzyme is found not only in our liver, but in sensitive tissues like the eye, brain, kidney, breast milk-producing glands, and our reproductive organs. The levels in sperm suggest a protective effect. Taurine is described as a major antioxidant, but it's really only good at squelching one type of free radical, but that free radical produces pro-aging toxins like advanced glycation end products, so that squelching activity is an important function. In addition to our brain, taurine is also found concentrated in our muscles, where it's involved in energy production. Presumably that's why it's put into energy drinks. Does taurine help with cognitive or physical performance? Probably neither. Like in this study, no benefit for either physical or cognitive ability, with some studies suggesting taurine actually undercuts some of caffeine's beneficial effects on cognition or vigor, or that it helps with one kind of cognitive task but hurts performance of another. Taurine may be more red herring than Red Bull, as the human studies often cited to support it have been improperly designed, lack appropriate controls. Put all the studies together, there's little evidence that taurine increases endurance exercise, and it's unclear whether there are any sports benefits like reducing muscle soreness or speeding recovery. Taurine injection might even be detrimental to maximal muscle power in non-caffeine consumers. The picture is just really unclear, which is why I've never really paid much attention to it until boom! This study came out, suggesting taurine deficiency was a driver of aging. It was published after I had already submitted the manuscript for my longevity book, How Not to Age, so I've been eager to dive into the topic to see if there was anything there. As we age, the taurine levels in our body fall by as much as 80%. This may be due to the depletion of the taurine-synthesizing enzyme in our liver, suggesting we may need to start getting more taurine in our diet as we age. The reason it was concluded that taurine was a driver of aging is because when attempts were made to restore youthful levels in animals through taurine supplementation, this reversal of taurine deficiency increased the health of worms, rodents, and primates, and increased the lifespan of worms and rodents. We'll dig into this important study next. The level of taurine in the bodies of mice, monkeys, and men and women declines with age, dropping by nearly 80% over the lifespan. This is due, in rats at least, to a decline in the synthesis of taurine. Would there be any benefit to restoring youthful levels through taurine supplementation? After all, lower taurine levels have been associated with all sorts of disease conditions of the bone, blood, eyes, heart, cancer. Of course, just because there's a correlation between lower levels and disease doesn't necessarily mean that lower levels cause disease. It could be the other way around, where, for example, disease leads to lower taurine levels. In my last video, I talked about how taurine is an antioxidant in the context of inflammation, so in the context of disease, more taurine may just get used up. The only way to know if taurine may help is to put it to the test. We know blood concentrations of taurine declines with age, so to investigate whether this decline contributes to aging, researchers fed taurine, or not, to middle-aged mice until the end of their life, and taurine-fed mice lived longer. Significantly longer, like the human equivalent of 7 to 8 years longer, and they had only started the taurine later in life in middle age. Now, a meaningful anti-aging therapy should not only improve lifespan, but also health span, the period of healthy living. So researchers then investigated the health of the taurine-fed middle-aged mice and found, compared to the control group, improved functioning of bone, muscle, pancreas, brain, fat, gut, and immune system, indicating an overall increase in health span as well as lifespan. They also tried it on other species. Taurine didn't make yeast live longer, but it did increase the lifespan of microscopic worms. 10% or more increased average lifespan in middle-aged worms and mice. And the mice didn't just live longer, but also healthier, with improvements in strength, coordination, and memory, as well as attenuation of multiple hallmarks of aging, such as cellular senescence, DNA damage, chronic inflammation, many of the aging pathways I talked about in my longevity book, How Not to Age. And in middle-aged rhesus macaque monkeys, 6 months of taurine supplementation led to positive effects on bone health, metabolism, and apparent immune health. There were similar health effects in monkeys who were in the middle-age equivalent of a human about 45 to 50 years old, but that's still 15 years for a monkey, which is why it's so hard to do longevity experiments on monkeys. If you're a microscopic worm, middle age is just 2 weeks, so it's a lot easier. But researchers did find that even just 6 months of extra taurine had beneficial effects on most tested health parameters in middle-aged monkeys, including 1 or 2 fewer pounds of weight gain, better bone mineral density, better blood sugars, and lower measures of inflammation and oxidation. If you take people and have them exercise, at least in active individuals, exercise increases the concentration of taurine in the blood, so that might even partially explain the anti-aging effects of exercise. The bottom line is that taurine supplementation makes animals live longer, but what that means for people is unclear. This is not the first time benefits of taurine supplementation have been demonstrated in lab animals, reducing blood pressure in rats, or reducing atherosclerosis in the coronary arteries of rabbits fed cholesterol. But the extrapolation of findings from animal studies is difficult due to the problems not only with dosing, but the biological differences between species. For example, the final step in taurine synthesis in rodents involves a completely different enzyme than in people, and is actually much more efficient in them than in us. But maybe it needs to be so much more efficient because the normal levels in the blood and brains of rodents may be as much as 10 times higher, potentially making them more susceptible to problems with slipping levels as they age. Unfortunately, little is known about the effects of taurine supplementation in humans. Taurine levels decrease with age, and taurine supplementation to reverse this trend can increase the lifespan of animals by countering the many drivers of aging and boosting health in the process. In people, lower taurine levels correlate with worse health, but the missing piece, a randomized clinical trial of taurine in people. What should we do while we wait? Correction of late-life taurine declines in humans could be beneficial for cognitive performance, energy metabolism, sexual function, and vision, but clinical studies remain to be performed. Visit NutritionFacts.org/audio to see all the podcast episodes with descriptions that include links to their associated videos. Sources cited and other details are available on each video's page. Information about my books, How Not to Die, How Not to Diet, How Not to Age, and my latest books on Ozempic, and a new one just out on lowering cholesterol naturally, is at NutritionFacts.org/books, and all proceeds from book sales go to charity. And sign up for our free newsletter at NutritionFacts.org/subscribe to stay updated on the latest bite-sized videos and articles. NutritionFacts.org is a science-based nonprofit, and everything on the website is free. There are no ads, no corporate sponsorship, strictly non-commercial, not selling anything. Just put it up as a public service, as a labor of love, as a tribute to my grandmother, whose own life was saved with evidence-based nutrition. Thanks for listening.